Welcome to AI Frontiers, your weekly deep dive into the cutting edge of artificial intelligence. Today, we're sifting through a fascinating collection of research papers, primarily from the realm of computer science, specifically within computation and language, often abbreviated as cs.CL. We'll be synthesizing recent advancements and illuminating key trends and findings from September 15, 2025. Your journey through AI's language frontier begins now. We'll be setting the stage with an overview of computation and language, exploring emerging themes, critical discoveries, and the methodologies unveiled by researchers. Finally, we'll spotlight innovation through three seminal papers. Let's start by understanding computation and language, the very engine of AI-human interaction. This area focuses on AI that can understand, generate, and process human language. It powers everyday tools like predictive text, sophisticated translation software, and chatbots, while also enabling complex data analysis. It's a crucial bridge between linguistics and computer science, vital for making AI more accessible and powerful, and it's driving innovation in how we communicate with machines. Our first major theme is the continued rise of advanced large language models, or LLMs. Researchers are intensely focused on enhancing their performance and addressing their limitations. This includes integrating LLMs for specialized tasks, like automatic speech recognition, as shown by Anne and colleagues. Bhattacharya and their team are improving LLM reasoning through self-correction, and efforts are underway to tailor LLMs for specific applications and domains, exploring the synergies between model scale and data. Theme 2 revolves around rigorous LLM evaluation and benchmarking. The goal here is to understand their true capabilities and flaws. This involves assessing LLM's understanding of fine-grained linguistic phenomena, as explored by Acharya and colleagues. We see the creation of challenging benchmarks for fact-checking in critical domains, like the work by he and collaborators on medical information. Yim and his team are evaluating medical question-answering systems effectively, while Marcuzzo and colleagues probe abstract moral reasoning in LLMs, all aimed at developing metrics aligned with human comprehension. Our third theme addresses practical deployment and ethical considerations for LLMs. This encompasses efficient and local customization methods, such as the framework introduced by Zhou and co-authors, which also addresses privacy concerns in LLM adaptation. Plyler and his team are working on detecting AI-generated text to combat misuse, and Kubis and others are focused on preserving language understanding via speech input. The overarching aim is to balance scalability, privacy, and ethical deployment. Theme 4 explores enhancing LLM interaction through techniques like in-context learning and retrieval augmentation. Quion and colleagues are improving demonstrations for in-context learning by focusing on topic coverage for more informative retrieval. Ruprecht and his team reformulate role-playing as a retrieval problem, inspired by retrieval-augmented generation to enhance authenticity and in-character consistency. Let's dive into some key findings that are pushing the envelope. In low-resource translation, simpler transformer models are surprisingly excelling, as demonstrated by Bonfanti and colleagues. However, even advanced LLMs still struggle with fine-grained linguistic nuances, a finding from Acharya and others. The MedFact paper by he et al. Highlights how over-criticism and localization errors challenge medical fact-checking. Meanwhile, Bhattacharya's work shows that refined LLM reasoning leads to better supervision signals, and specialized benchmarks reveal LLM brittleness in complex reasoning tasks. This brings us to the methodologist's toolkit, a synthesis of techniques driving LLM advancement. We see widespread adoption of fine-tuning, adapting pre-trained models to specific tasks, as exemplified by Bonfanti et al. Reinforcement learning, is being used to enhance performance beyond supervised learning, with Zheng and colleagues proposing novel frameworks. Retrieval-augmented generation, or RAG, is crucial for grounding LLMs with external knowledge. The LLM as a judge approach, explored by Pradhan and team, offers scalable evaluation using LLMs themselves. Finally, the creation of specialized datasets is fundamental for rigorous evaluation. Let's spotlight selected research. Translation for under-resourced languages. Focusing on the paper, a comparison of pipelines for the translation of a low-resource language based on transformers by Bonfanti and colleagues. This work tackles French to Bambara translation, a low-resource scenario. They explored 3 pipelines: a simple transformer, fine-tuned Llama 3, and language distillation. The key finding is that a simpler pipeline outperformed more complex ones on mixed-domain data, offering practical solutions for bridging language divides, and demonstrating the effectiveness of tuned simple models for low-resource NLP. Next, we examine selected research, refining LLM reasoning with self-correction, based on Audited Reasoning Refinement, fine-tuning language models, via LLM-guided stepwise evaluation and correction, by Bhattacharya and his team. Addressing the challenge of scarce human supervision for task-specific reasoning, they leverage LLM-generated traces, refine them for supervision, and create high-fidelity datasets. This method enables scalable adaptation in data-scarce domains and represents an innovative approach to data augmentation and model training. Our final selected research paper is Selected Research, Probing True Language Understanding, from the work titled Does Language Model Understand Language by Acharjee and colleagues? They investigate whether LLMs truly understand subtle linguistic phenomena by introducing the lucid dataset for tense, negation, and modality. A key finding is that compound beta showed strong alignment with human interpretation, highlighting remaining gaps in LLM linguistic comprehension and developing critical tools for evaluating deeper understanding. Looking ahead, the path forward in AI language research involves developing more efficient, specialized, and robust LLMs. This includes creating advanced evaluation benchmarks for cognitive abilities and prioritizing ethical considerations and bias mitigation. We'll also see exploration of multimodal LLMs that process text, image, audio, and video. Efforts will intensify to integrate LLMs for scientific discovery and creative applications, transforming how we interact with technology and information. This AI Frontiers presentation was synthesized from 54 research paper summaries, utilizing AI tools like GPT models for text generation and DeepGram for TTS synthesis. Image generation was performed via Grok. All synthesized content underwent human expert review. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses archive preprint server content under its AI terms of use. AI Frontiers is not affiliated with or endorsed by archive preprint server. That's all for this week's AI Frontiers. Subscribe to our YouTube channel for weekly deep dives and never miss an episode on the cutting edge of AI. Join our community of AI enthusiasts and researchers as we explore the future of artificial intelligence together. Until then, keep exploring and keep questioning.